Alright, in this experiment we're going to be making copper carbonate. This one's a lot more laid back than the TACS experiment. There's no dangerous chemicals. You don't need any special protection. What you're all going to need for this one is a shallow dish, powdered copper sulfate, you don't dissolve it, baking soda, some distilled water. The amount of distilled water isn't really important. A 1 teaspoon measure, and a stirring stick. In this case I'm using a wooden dowel. Alright, for the procedure for making copper carbonate, the first thing you want to do is take 2 teaspoons of baking soda or sodium bicarbonate, which I've already done just to save time, and you just add that to the distilled water. I'll move this up. And then you take your stirring rod, or if you have a electrical or mechanical mixer, that's perfectly fine too. And you just stir it up until all the baking soda is dispersed in the water. Then what you do is you take 1 teaspoon of just powdered copper sulfate. Come on. There. And there isn't really a scientific way to do this, and you add it to the sodium bicarbonate and water mixture. As you can see, it becomes very foamy. I hope it doesn't come over the top of my cylinder here. And as it's reacting, the particles you can see falling are freshly formed copper carbonate particles. This reaction can be sped up by stirring it, which I'm going to do just to save time here so the video doesn't get overly long. If you let it go, the reaction should take about 2 or 3 minutes. As you can see, it's already starting to drop down. And this is where your shallow dish comes in. Because after the foam reaches about the same level that the water was originally at before you added anything to it, so about here in my case, you pour it into the shallow dish. And it may fizz a little bit, that's not a big deal. And you let it sit for about 10 to 20 minutes, and we'll come back in about 5 or 10 minutes and then check on it, and if it's not there yet we'll wait a little bit longer. Alright, here we are about 10 minutes after we poured the copper carbonate into the shallow dish. As you can see, it might not be the best on this camera, but it's all settled to the bottom because it's completely insoluble in water, which is awesome if you want to actually gather the powder later on. To separate just the copper carbonate away from the solution, what you need is 1 sheet of filter paper, or if you don't have a very big budget, I completely understand. I'm just using a coffee filter, and then a second shallow dish. Both of the dishes can be plastic, by the way. This isn't corrosive. This isn't like ammonia. And it's very simple. I can just do this with my hands. It won't hurt you at all. But you just pour just the liquid in its entirety through the filter paper, bring it together at the top, and just squeeze. You don't want to squeeze too hard or you'll break the filter, but you just want to strain out the excess liquid, which you can see dripping off my hand and apparently down my sleeve. Once you don't have to get all the liquid out, just most of it. It should be kind of a squishy, almost like a silly putty consistency. You can open the filter back up, and all this blue, green, it's under the shadow of my hand, all this blue-green mud is copper carbonate with a little bit of liquid remaining. All you have to do is set this out on a sheet of aluminum foil or just something that won't let water through. Wax paper would be fine, and just let it dry for, I don't know, 2 or 3 days. And after that, you can just take a stiff brush, like I use a toothbrush, and a little bit of manual just hand pressure, and it'll just come right off, and it'll be a nice blue color. The liquid, on the other hand, can be discarded, or it can actually condense small blue crystals that are just cool to look at under a microscope. And to condense the crystals, you just leave the liquid sitting out just about for as long as you need to let the coffee filter dry, which is about 2 or 3 days, and at which point you'll see little blue crystals. At that point, the liquid can no longer be used and it can just be discarded. It's of no use anymore. Alright, this is the synthesis of tetraamine copper sulfate, or TACS for short. What you're going to need is ammonium hydroxide. I'm using 29.4% concentrated ammonium hydroxide. And I've already pre-measured 7.5 milliliters because I had to do that outside. You're going to need powdered copper sulfate, just crystalline copper sulfate, a pipette, a 1 teaspoon measure, 25 milliliters of distilled water, a pair of safety glasses. I actually left my good ones in the chemistry lab at school, and a pair of rubber gloves. Alright, for your procedure, what you want to do is, first you want to take your powdered copper sulfate and measure out 1 teaspoon and mix it with 25 milliliters of distilled water. Distilled just helps keep the solution clear after it's made. I used a little less this time, 3/4 teaspoons and 25 milliliters. That part isn't really important. And then I measured out 20 milliliters already just to save time. It can really be any amount, just keep it proportional. Next, you measure out, in this case I used about 8 milliliters of ammonium hydroxide. If at all possible, you want to do that in a fume hood, just because the fumes are pretty nasty. That's basically all the setup you really need. And to form TACS, or tetraamine copper sulfate, you use your pipette and you gather up a small amount of copper sulfate. I'll dump all of that into this vial eventually, just not during the video. This part you also want to do in a fume hood, just because of the fumes. I'm doing this in my basement actually, so. And as you can note, I'm wearing rubber gloves and safety glasses. And then all you do, once you have all your copper sulfate dissolved and your ammonium measured out, is open the cap and then just slowly drip in the copper sulfate. And there you have it, tetraamine copper sulfate. You can make it darker by just adding more copper sulfate to the solution, but because of the fumes I wanted to minimize the time that the cap was off that vial. As you can see, it becomes a very nice blue-purple. The solution I made in a prior experiment is actually purple, but I added a lot more copper sulfate. Another cool thing about TACS is that it can be returned to its original light blue color, like the dissolved copper sulfate. That's very, very simple. All you really need to do is take the vial of TACS and put it in a shallow dish for generally about 24 to 48 hours, and after which period it will turn back into a light blue solution. The ammonia will evaporate and it will just leave copper sulfate dissolved in water.